fully 3D printed or with a concrete base for your premium lamp. With very low costs, you can start a small-scale mass production right in your kitchen, even with your mom, and make real money. The best part, you get this model from me including a commercial license. The concrete base has a material cost of about $1, so production is extremely cheap, no matter which of the two manufacturing methods you choose. I started printing the lamp base file. For the mold, several parts need to be printed. If you want a 3D printed base instead of a concrete one, this print is enough. The print is finished, but there's still some work ahead. For the connection, I simply went with a plug-in design. Many other connection types that work for 3D printing are problematic when casting in concrete, so I chose the simple plug-in method. These plates here were my test print. The plan is that I can quickly connect any lamp I design using this connection. It saves a lot of time in the future. You don't need to model in Blender or CAD, you can just use the Bamboo Lab Make My Vase mode. Quickly create a vase and place it on the connector. I'll show you how so you can save time on your own models. In one of my recent videos, I already created a small lamp. I liked the basket pattern I showed there so much that I'm modifying it slightly. I also plan to print a straight version in a larger size using a 0.8mm nozzle. Now here's the connector in Blender. I can't change its size. Otherwise, it won't fit the base. The lamp itself can be scaled, but it must touch the connector and not extend beyond the sides. Then I have the perfect lamp, which I export as an STL and import into the slicer. I'm printing with a 0.8mm high flow nozzle. I switched the wall generator from Classic to Arachne. The print will take just over 2 hours. The main issue in the settings was the filament. I used PETG, and I'll explain why in a moment. Other parts for the mold are already printed. Here's the setup for our silicone mold. I still need to do some finishing work before assembling it to cast silicone, which I can then use for concrete, plaster, epoxy resin, and more. It looks pretty good. My bamboo is already printing while you remember to subscribe to the channel. I'm printing with the large nozzle. Look closely, I know you enjoy big nozzle videos. The nozzle is finished, so it's time for a quick test. Here's the connector again. This is how it looks when stacked in free software like Blender. Now for the cable, I'm using an E27 lamp socket, and there's extra room underneath for a slightly thicker cable. About the lamp, almost all models you print should use LEDs instead of regular bulbs because of heat. Even with LEDs, you shouldn't exceed 10 watts. For this model, I ordered several 8-watt bulbs. PETG lamps that are open can handle this wattage easily. PLA lampshades aren't suitable unless you stay under 6 watts and the shade is open to let heat escape. I even ran my model with a 10-watt bulb for several hours. No issues because it's open. A light test. Anyone who's filmed a glowing lamp knows how hard it is to capture the light correctly. That's why it looks overexposed in the footage, even though I adjusted the settings. With a black or beige base, the lamp already looks good as a 3D print. The base is made of PLA, which is perfectly sufficient. Time to prepare our mold. Silicone captures details extremely well, which is why the seam and all filament layers need to be processed beforehand. This time I also want to spray the less important areas to see if it helps the silicone cure faster, since silicone often takes longer to cure on smooth PLA surfaces. For the initial sanding I use a sanding sponge with medium grit, and for the final pass a finer sandpaper. An ultra-fine grit like the one I used isn't necessary. Something moderately fine is more than enough. Sanding PLA is actually quite easy. The main thing to watch out for is not staying too long in one spot, because friction causes heat buildup and the material can deform. With a lightweight sander and a soft sanding sponge attachment, you can work even faster. Spray filler. I love this stuff. It fills all the gaps and scratches. Of course, the link is in the description. Shake the can thoroughly and then start spraying. It doesn't have to be perfect because it will get a fine sanding afterward. After a few hours, I continue with a fine sanding sponge. It works well but creates a lot of dust, and the sandpaper clogs quickly, which is why I prefer wet sanding. With water it goes really fast. Wipe it down with a cloth, let it dry briefly, and then apply the second and final spray coat from the other side. At this stage, I can also fix any remaining grooves in the model. Yes, there are several work steps. The actual working time is short, but waiting for drying and curing takes longer in this kind of workshop environment. I like how it looks. Now I attach the base to the plate using double-sided tape. It's very important that it sticks firmly, otherwise the model could start to float, and then all the work would be ruined. Mold making silicone is not cheap. It's also crucial to place it exactly in the center, otherwise the silicone walls will be thicker on one side and thinner on the other. This part also needs to be firmly attached. The printed model ensures that I don't use too much silicone. Again, try to position it as precisely in the center as possible. I'm providing the complete files for the mold and the basket pattern lamp in the description, including a commercial license. The previous model was free and was downloaded over 1,000 times in just 1 month. That really makes me happy, but for commercial use it's not ideal if thousands of potential competitors have the same file. That's why this licensed file is not completely free. I hope you can understand that. Now I seal the entire mold with hot glue so that no silicone can leak out. Looks good. Let's move on to the mold making silicone. I prefer a medium hardness, not too soft and not too hard, which makes it ideal. Today I mix it in a cup using a scale in an equal ratio. Estimating the amount is always difficult, so I prepared a small extra model. If I end up mixing too much silicone, I'll use the leftover material to make a small concrete candle mold instead of throwing it away. Here's the good part for you. You don't need to test anything. You can use these amounts directly. I used the same amount of each component for a total of a little over 600 grams. One thing that's extremely important is mixing thoroughly. If there's any unmixed material left at the bottom, it won't cure and you'll end up with a hole in the mold. So make sure to mix really well, including all corners and the bottom. My vacuum chamber removes all the air from the silicone. Good silicone can degas on its own, but often not well enough, which can lead to small air holes. After all this work, that would be a disaster. If you're serious about getting into this business, I recommend a vacuum chamber. I've linked one in the description, otherwise I'll show you how to pour properly without one. On the vacuum, the air is pulled out and it looks like the silicone is boiling. This takes about a minute. With epoxy resin it takes longer, and because the volume expands on the vacuum, you should always use a much larger container. With epoxy this effect is even stronger. Finally we're ready to pour. I recommend pouring from one side so the silicone can flow and distribute itself from the bottom up. If you pour too quickly from all sides, air can get trapped, and air means holes, especially if you mix the silicone without a vacuum. Pour very slowly so the air can escape from the thin areas. Just to be safe, I placed a bit of weight on top. The worst case scenario is the model starting to float, but the tape should be strong enough. I used almost exactly 600 grams of silicone. A small amount was left over and went straight into the small mold. After that, I had to mix just a tiny bit more silicone. I always let everything sit a few hours longer than necessary rather than too short. Patience, my friends, and it will turn out well. In the meantime, I started printing the lamp again in translucent PETG so I can directly compare the difference. One day has passed and the silicone casting molds are finished. So, the hot glue has to go. Important, you need to be careful here so you don't cut yourself. It's best to do it like I do it like a professional. This already looks good. I've gotten very good at this by now and I never cut myself. Loosen the casing as well and pull it apart with a bit of force. On the lower sides there is double-sided tape, which makes everything quite tight, but it still comes off well. What is new for me with the large silicone mold is that it doesn't have a closed bottom. Because of that, it won't work like a candle container with a bottom, where you can usually push everything out properly using a pump and air pressure. I cut away the excess silicone and removed the remaining tape as well. From the top, I will then pour the concrete in. Since this kind of model was a first for me, I really struggled to get the inner part out. Air pressure doesn't help here because there is no bottom and the air just escapes. After many attempts, I decided to remove the center part using a drill. So I took a cordless drill and a wood drill bit and drilled several holes into it. It's not that bad. The inner part was only there to save silicone. But I still need it so the concrete walls will be straight later, so I printed this cylinder again. But 0.3mm smaller so it fits in loosely. Both files are also available for download. I think you might also have to destroy one part and reprint the smaller one to use later. Then I continued cutting it out with cutters. And I'm wondering, who of you would dare to stick your hand in there now? So the mold is out, and yes, if you don't want to do this, you can simply print the model purely in a 3D print style. It also looks great. Everything is finished, well, almost everything. I still need to reprint this part, so this now goes in so the concrete wall stays straight. Looks good, right? Concrete prices can actually be pushed down quite well nowadays. I'm adding 6mm glass fibers. I no longer order cement from Amazon, and this is the cement class I use, which is already available from around €6 per 25 kilogram bag. Quartz powder so the liquid doesn't rise to the top and you get a nice smooth surface plus quartz sand and flow agent. I really use very little of it now, one drop too much and it ruins the entire mixture. I really struggle with estimating the amount. Do I need 500 grams, 1 kilo or maybe 2? That's why I mixed a bit more at first and have small candle containers ready in case there is too much concrete left over. That's only an issue the first time. After that I know the approximate amount I need. You also shouldn't use too many glass fibers, otherwise the surface becomes rough, about 1.5 grams per 1 kilogram of finished concrete mix. My mixing ratio is 1 part cement to 2 parts quartz sand, and I also count quartz powder as sand here. Mix everything very thoroughly. I use the transparent cup here so it's easier to see for the video, but you should really mix concrete in mortar buckets. I usually use 5-liter black buckets, they cost about €2. And you can mix proper amounts in them, so if you want to recreate this, I recommend mixing your first batch for this project at 800 grams. That will fit well. I used the 1 kilogram plus 20 gram container and didn't tear it. You'll have to judge the liquid yourself to know when the consistency is right. Once the concrete is well mixed, let it sit for 2 minutes and then mix it thoroughly again. Up to this point there are already many steps, but once you have multiple silicone molds, you'll be able to produce many concrete parts in about 20 minutes. The path to this point is just a bit long. This was also my most awkward model to handle so far. When designing it, I imagined everything differently somehow, but I kept adding small amounts of concrete and then turned on the vibrating table. In the next video, I'll show you how to build one yourself cheaply. Knocking is important, but vibration is simply much more comfortable and faster. It's best to remove the printed models as well and tap lightly on the walls. Then cover everything so the moisture doesn't escape too quickly and wait a bit. If you don't want to use foil, you can place a large container over it and put a few wet tissues next to it so there's some humidity inside, and that's it. About 20 hours have passed now. The foil comes off, but I let it cure a bit longer. Time to take it out. The few concrete splashes on top have also hardened and I should have smoothed them out earlier. That way I'd have less sanding to do and the bottom would be flat. While removing the silicone, I already noticed some larger holes that don't look very nice, so I wouldn't sell a piece like this. But since the video needs to be finished and I haven't uploaded anything in 2 weeks, I'll leave it as it is and I believe you'll do it better. Trust me, holes in concrete are okay. And yes, your mom has them too, but if a few large ones stand out that much in a product, I wouldn't list it. Since the second lamp is also finished, let's take a look at both of them on the concrete base. And in the meantime, my lamps have also arrived. Lamp goes in 7 watts, absolutely fine with PETG. And as I already said, I personally wouldn't use PLA, especially not if I'm selling it to customers. The small holders can be glued in place with super glue once everything fits. Feed the cable through the concrete and I think the whole thing already looks pretty good. With lighting, I have no idea whether it's even worth doing light tests here. I just can't manage to film it in a way that looks like it actually looks and isn't overexposed. Which lamp do you like better, white or transparent? Or maybe it's best to just print the base as well and save a lot of work. All files with a commercial license can be purchased as a one-time purchase, which also helps support me. Say hi to your mom from me. Kiss.